Hello there, this is our group presentation for SOFT253, and our group letter is R. So I'm recording this using a screen recorder, and this is connected to my microcontroller with the sensory board loaded on top of it. First of all, I'm going to start by running the program. As you can see there, we've got some lovely ASCII art that took us some time to make, and we thought that'd be a nice little addition for your viewing pleasure. So first of all, we've decided we're going to start by talking about the best place to start, we thought, would be talking about requirement number 7, and then we'll go ahead and evidence all the other requirements after that, but it's probably best to show you the full functionality of the serial input/output system straight away. So the first serial input was read all. So the timer at the beginning is set to 15 seconds, so there should be about 1 or 2 records in there by now. So if I type in read all, there you go, you can see there's 2 records there, so that's read all done. Now what I'm going to do is go ahead and press delete all, so delete all, and now we can see we've deleted 2 records from there. One thing to note at this point is to say that we've actually managed to implement the backspacing. Now backspacing, so if I type in read, it records the fact that we've backspaced, and go ahead and type read all again, and it can show you that stuff there. So it cancels out the backspaces that you do by resetting pointers. So now we're going to go ahead and show read and then a number. So if I go ahead and type in read 2, it shows us the 2 there. Now if I type in a number greater than 2, read 6, it's only going to show the maximum number of hours we've accumulated and logged. So now I'm going to go ahead and press delete, so it's going to delete the latest record. So there you go, delete that. And I'm going to read again. And you can see that here you go, you can see 2047. Which one have we gone? Yeah, 47 has gone straight into there, and the 02, all the records has been deleted. So now we can go ahead and I can show you set date. So now set date sets the system time and sets the system date. So we're going to go to set date, and I'm going to put in the day. So we're going to say it is today, so the 14th of May, and May is the 5th month, and we're going to say 2017. I'm going to go ahead and there you go. You can see date updated to 14/5/2017. It's going to wait a few seconds just so I can evidence this. But while we're doing that, I'm also going to set the time. So if I type in set time here, I can show you that I can just set the time to the current time, which is 23:27, and the seconds we're going to say are 30. So current time updated to Sunday the May the 14th, 23:27:30. So I'm showing you some nice kind of logging there of your actions, kind of like evidencing those requirements there. So now we're going to go ahead and read all. You should be able to see. There you go. So the latest value down here, if you can see my cursor, is 23:27:43. Obviously because of the interval, it's gone up, and 14th of May 2017, which is brilliant. So now what we can do is we can change the interval at which the system samples. So we're going to go ahead and set t to 5 seconds. I'm going to quickly read all. I'm going to count to 10 seconds. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. You should be able to see, there you go, there's some 2 extra new values put into there. So now what we're going to do is we're going to change the state. So we're going to stop sampling. So first of all, we're going to change state to off. Nice output there, telling you that sampling has now been turned off. So we're going to quickly read all the values again. So as you can see, the last time entry was 23:28:39. So now we're going to try read all again, just to evidence the fact that sampling has in fact been turned off. And there you go, you get the same time again, 23:28:39. We're going to do that one more time just to double make sure that everything has definitely been turned off there, so 23:28:39. Okay, so now we're going to go on to displaying the logging functionality of our system. So if I go ahead and type in logging on, by default we decided to turn logging off as it's a bit messy and gets in the way of anyone who wants to type in commands, so go ahead and press logging on. It's going to log all of the messages that are put in the queue and output them there. Oh, I haven't turned sampling on again. So sampling on. Ooh, sorry, let me start that. State, isn't it? State. Oh god, keep experiment state on. There we go. Sampling's now been turned on, so every 5 seconds we should be able to see a result, as you can see. There you go. And that is logging for you. Okay, I'm going to go ahead and turn logging off. Touch the wrong thing. There you go. There you go. Right, so logging's now off, unless there's stuff still in the queue waiting to be sampled, but logging now should completely be off. However, sampling is still on, so the program is still storing all that data to the internal RAM. Now what we're going to do is we're going to run through all of the requirements. I think that's everything asked for the serial input output. So we're going to run through all the requirements, and Dan is going to say the requirement, and then I'm going to speak about how we did that.
Okay, requirement 1. This device shall periodically measure sensor data, including temperature, pressure and humidity, at a fixed and known rate using a timer interrupt. The default shall be once every 15 seconds. Okay, so I'm sure we provided enough evidence already to show that the device actually does periodically measure data in that way, and I've also shown how we can change the interval also. Requirement number 2: the device shall be able to log the date, time and sensor data in the internal RAM memory of the STF401. So, as you can see, we've got the date, time, temperature, pressure and humidity in the internal RAM, and that's where it's pulling the values from, and that is written in a circular first in, first out buffer. Requirement 3: when enabled and where possible, you should log additional data to the serial interface to evidence these requirements. You may also use this facility to help debug your software. So yet again we have done that. So in this, you can see here we've said sampling on, logging off, logging on, logging off, etc. You can see logging's down here also. So this just shows that we've actually gone ahead and evidenced this requirement. So evidencing everything that we're doing and displaying the diagnostic data to you. Requirement number 4: when memory is full, the oldest sample shall be overwritten using circular first in, first out buffering. Okay, so to go ahead and evidence this, the best thing to do is set T to something like, let's say, 0.5. So we've already got quite a few values stored in our database over this time. Not database, sorry, stored in our internal RAM so far. So what we're going to do is wait a few seconds, and I'm sure it should be able to get. I'm sure you'll be able to see a lot of data there showing in. The maximum value we have set is a constant at the start of our source code. You can go ahead and change this value if you want. So the maximum value at the moment is 120, but more records can be kept if you want to change that. So now I'm going to go ahead and press read all. So take note of the first time, that's 0202. Now if we go ahead and do it again, you can see that the time has actually been overwritten in, first out buffering. So it was no longer, I'll go up and actually show you that myself once it's finished reading out all the values. Keep going. There you go. Now I can go back up to. So you can see here the time is 23:31:04, and the previous time that we managed to read from is 0202 up here. So that shows that. So requirement number 5 is pretty self-explanatory. We have used C, C++, and we've also used the embed libraries RTOS. Requirement 6: you should write your code to minimize power consumption where possible. So we found it pretty hard to log and provide evidence of this in our actual serial output. So what I wanted to say was just that if you have a buzzer code, you can see at any given point we're using really power efficient functions such as signal wait and signal set. We're also using mutexes to make things thread safe and prevent thread starvation and deadlocks. To add to that, we've just if you look through any of the while loops or anything like that, we're not using methods to constantly
read from the sampling data or constantly look at things. It's very kind of power efficient, so you can go through that in your own time.
Requirement 7 has been done at the beginning. Requirement 8. Serial communications must be performed in a separate thread so that it does not block or interrupt the CPU when measuring sample data. Data sampling has the highest priority, but must remain responsive throughout the lifetime of the application.
Okay, so in our source code you'll be able to see that there are actually 2 threads that run serial communications. Now, if you, in your actual documentation, you stated that we could use one thread for input and a separate thread for output, running with a message queue or something like that. So we decided that to get around this issue of obviously having this logging information and the serial output, such as read-alls, return values, what we actually wanted to do was go ahead and be able to do both in one. But we actually started to use something called a mutex, which prevents one, for example, when we're logging, if I show you here, it's probably actually quite a good way to evidence this. So if I start logging now, we're going to set logging to on. You'll see it's logging, 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 logging. Now if I go ahead and type read-all, it doesn't actually do that thing where it cuts across the screen and stops that. So that's mutex there, showing that only when read-all's running, it locks that mutex so that it can't do, and then you go back to the old. Now it's pulling everything out of the queue very quickly there because there was a queue there waiting for everything, so that's just reading off the other values, and now it's back to the original sample rate. So I'm going to actually set the T to 5 now because it's a bit of a pain when you're logging something that quickly. And then I'm going to turn logging to off. Spelling. There you go, logging should be off. Maybe it'll pull one more value from the queue or something like that. Okay, so now if we go ahead and talk about the 9th requirement.
You shall mitigate against the occurrence of deadlocks and or thread starvation and add code to take appropriate action. This could include timeouts with status checks and or a watchdog.
Okay, so in this requirement, we used to mitigate against thread deadlocks and starvation, obviously using things like signal wait and mutexes, prevents any thread from starting out or anything like that. We did encounter a couple of issues early on when we were first programming, but we managed to get around that using mutexes and signal waits.
Requirement 10 is pretty self-explanatory. It's just about software should be properly indented, sufficiently commented at module level, function method level, and line level where appropriate.
And you can go ahead and look at that in our source code yourself. Thank you very much for this project. It has been extremely interesting, and it has really opened our eyes to how important it is to make our code efficient when it comes to the hardware. Thank you very much.